So obviously you're going to be using the functions string append, substring, maybe string length, probably string length. And like this is good practice for your assignments because believe me, on your assignments, you're going to get questions like this that are probably a little bit more difficult. But I mean, if you can solve this, you're on your way to solving the assignment questions. Okay? All right, well, let's try doing it again. So, as far as like, how do we think about this question? What is the first step? What is the first thing we need? What is the first thing that comes to your head when you're thinking about implementing this question? String length, right? We want to know how long these strings are so we can do something on them. Or, yeah, do something on the string that's called string. Okay, so assume you have the string length, okay? So you call string length, you get the length of your string. What do you do then? Come on. Who was working on this question? Come on. Yeah? Just like in roughly English, you don't have to like tell me the code, but like after you get the string length, what do? You figure out where the half is. So you divide the string length by 2. Because you're obviously going to need to know where the half part of the string is. Okay? So you get the string length, you divide it by 2, now you know where the middle part of the string is. What do you do next? Substring, right? Because now that we know where the middle part of the string is, the next step is to get the first half and get the second half. Okay? So how do we get the first half? We call substring. On that string, we start at 0, and we go to the half thing that we already computed. Right? We go from 0 to the half part. And then how do we get the last half? Yeah, so we call the substring on that string. We pass in that half value that we computed already, and then we just go all the way to the end. We don't pass in the third value because we just go all the way to the end. And then what's the final step? String append. You string append this substring with this substring on the other way around. Okay, so if you guys actually solve this, that would have made sense. But since all you guys are confused, I know none of you guys solved it, so I guess I'm gonna have to do it. Okay, so let's solve this question. Okay, so define swap parts, and it takes in S. Okay? One sec. Okay, so like I said, the first part is to find the middle of the string. Okay? How do we find the middle of the string? We call, well, again, I'm just going to write, I'm not writing this in any particular order. This is kind of the way I think about the question, and that's how I'm going to go about solving it. So the first thing, like I said, the first thing we think about is we need the string length. So we call string length on S. Okay? And then, like I said, we want to know where the half part is, so we're just going to divide this by 2. Okay? But the problem with this is, if we do string like angel, for example, in that first example, if we did angel, and then we had string length of angel, it would be 5. And then we would do 5 divided by 2. That would give us 2.5. But if we remember from the contract of substring, we can't pass in a decimal value. It doesn't make sense to pass in a decimal value for a substring. You can't start at index 2.5. There's no such thing as index 2.5. Okay? So I didn't actually mention this, but there's one more thing we need to do. We need to floor this. So what does floor do? It just rounds down. So floor of 5.5 is 5. Floor of 2.5 is 2. All we're doing is we're getting this down to a whole value. And the reason for that is because we want to be able to use this in the substring function. Okay? Yeah? That's actually a very good point. And the point is, the function quotient does the exact same thing. And it does actually. So if we actually just called quotient on string length of s, and then 2, this would actually do the exact same thing. Because, well, I mean, that's what quotient does. So you know what? For that point, let's actually just use your implementation. We're just going to use quotient. Actually, no, I guess a lot of you guys probably wrote this one, so we'll use this one. Sorry, I'm not used to teaching. I know when I erase stuff, that means all you guys are probably erasing it, so probably not a good thing. But, actually, no, we're going to use quotient. It's definitely a better implementation. Okay, we're using quotient. I'm sorry. They both do the same thing. They both do the exact same thing. Quotient is just, well, here, let's see it. So what does quotient do? If we call floor of divided by string length of angel and 2, this is going to give, okay. Why didn't that work?
I think it's not right.
Oh, right. Okay, so we call this, we get 2. And if we call quotient on string length of angel and 2, we get the same thing. Okay? Yeah?
Professor, would that have worked if angel was a 6-character letter? With
Yeah,
quotient?
so let's try it. So if we call floor divided by string, the question was, does it work with an even amount of characters? So A, B, C, D, E, F, and then 2, we get 3. And then if we do quotient, A, B, C, D, E, F, oh, sorry. Quotient of this thing and 2, we still get 3. Okay? Because what does quotient do? Well, we're not going over that, but this is why you get the same. So you know what? We're just going to use the quotient one. Okay? So this gives us our midpoint. Okay? What do we do when we get the midpoint? Well, this is where we started saying we want to call substring. We want to figure out what the first half and what the second half is. So we're going to get the first half, we're going to call substring of s, because this is, remember, the first parameter has to be a string. The second parameter has to be a number, a natural number, and this is a natural number. And, well, okay, so this is actually the starting point. We're not going to be starting at this point. We're going to be starting at 0, because this is going to give us the first half. Okay? So this whole thing is the first half. Oh my god, this font is so small. Why didn't anyone tell me? Increase font to 11. Increase font to 12. Control plus equals. Okay. There we go. Okay, so that gives us the first half. How do we get the second half? We do substring of s. We're not going to start at 0 though. We're going to start at this place, because this is the half. This is the halfway point. We're starting at that point, and where are we going to? To the end. So we could write end doesn't work, but like we could specify some value here that would tell us go to the end, or we could just close it, because that's going all the way to the end. Yeah, and so this is giving us the second half. This is giving us the first half. And then at this point, all we do is we call string append. Not on the first and the second half, but on the second half and the first half. So this is the second half. This is the first half. We string append both of these. I think this is right. So I do this without actually like knowing whether it's right or not. So let's figure it out. Okay, so we're going to call swap parts on angel, and we get bleed. We're going to call swap parts on, what was the other one? Hot shots. Hot shots. No, hot shots. Something like that. Yeah, it works. Okay. Yeah? Over here. Oh. Are you talking about over here? Or are you talking about down here? Right here? Right here. Okay. Right. So if ever a function returns a string, you can assume that the quotation marks are already going to be there. So I'll give you an example. So the question was, how come in here we're not putting how come we're not putting the quotation mark here? Shouldn't this be a quotation mark? Because string append takes in a string, and you're not passing in a quotation mark there. And that's a good question. The reason we don't need to do that is this is kind of where tracing comes in, actually. So if you have a function, if its most simplified value is a string, then you can assume it's already in the quotation. So for example, if we call like substring of like hello, like, and whatever we pass in here, we're going to be getting a string out. And the reason we're getting a string out, just to go back to the contract, because the contract is very important. That's kind of how you determine what the input and the output for different things are. So going back up here, if we look at the contract for string length is it takes in an str and it produces a nat, and the contract for substring is it takes in an str nat and it produces a string. And because we know we're producing a string, regardless of what the function substring outputs, we know it's going to be a string. We know it's going to have quotation marks. And there's a good example. It has quotation marks because the substring function will always return us a string. And because it always returns us a string, we can't use it in other functions. Yeah?
Well, it's not just a question, but if you put the quotation marks out there, we should just have an answer with this quotation mark.
That's actually a good question. So let's actually try that. So the question was, what happens if we actually do put this whole thing in quotations? And let's try it. Let's see what happens. So we're going to string append that with the string append of this whole thing in quotations. Okay? And what happens? What happens if we call swap parts now? It'll work. If we call swap parts on whatever we pass in, it doesn't even matter what we pass in. It's just going to be that first string appended with that second string. So we can call swap parts on this string, doesn't matter, and it'll just do the same thing. We can call swap parts on the empty string, and it'll just do the same thing. Because it's just appending this string with this string. Now, we can also do this. Because this is also two strings. They're still two strings. It's just these two strings now, they're functions. And substring, as we saw, the contract for substring, I'm going to go back to it because it's very important. The contract for substring, it returns an str. And only because the contract for substring returned an str, only for that reason, do we know, regardless, only because it returned an str, do we know that both of these will be returning a string. That's how we know these are returning a string, because the contract for substring tells us that as long as you use substring correctly, the output will be a string. So we can pass that output into the input for string append, because string append takes in strings as its contract. So contracts are very important here, as you can see. The contract for a string append, it takes in several strings, and it outputs a string. Substring's output is a string. So we can use this output as an input to string append. Yeah?
When you were mentioning the contract of substring earlier, you said it was technically wrong because substring could take in one natural number instead of two.
Good question.
So how would you correctly write the contract of substring?
Yeah, so you guys actually don't need to know how to do this yet, but so over here I said the substring takes in these three parameters, but we saw that substring, you could actually do something like substring hello, and just pass in like 3 and close, and this would actually work, and it would return 0, 1, 2, 3, it would return hello. So in this case, you can ask the question like, hey, over here, you didn't pass in a second natural number, so how come this works? And the truth is, the substring function actually it still only has one contract, but for this course, you're never going to be in that situation where there's a parameter that can potentially be there and potentially not. For all the questions that you're given, you'll never have like a variable parameter. It'll always be like there's 4 parameters, or there's 5 parameters, or there's 2 parameters. How do you write the contract for something that has like a variable, that a parameter that might or might not be there? Don't worry about it. It's not part of this course. Because yeah, this is not really the contract for substring. It's one of the contracts, and yeah, it's not within the scope of this course for you to know why or the other ways to write the contracts. Are we good? Okay. Anyways, before I continue, I want to show you guys the actual solution that they had presented. So, if you notice in our solution, there was 2 instances where we used the midpoint where we used the midpoint. So if we go back to the solution that we had, you'll notice that this right here, quotient of string length divided by 2, this was used twice. Right here and right here. Okay? So this is where we're going to introduce the concept of the helper function. Because we're doing this computation twice, we don't necessarily need to have the same computation within our function. What we can do is we can just call a function called midpoint. So we can just simply do something like this. We can do define mid, and it takes in a string, and all it will do is it will return quotient on string length on s and 2. Or sorry, string length of s and then 2. We can just define a function that does this, and then rather than constantly calling quotient of this every time, we can just simply call mid on s. And same thing over here, rather than calling quotient 2, we can just call mid on s. Same thing, it'll do the exact same thing. But what have we done now? We have introduced a helper function. And a helper function is some function that's going to be used constantly throughout your code. And so rather than using that expression constantly, you're going to give it a name. And in this case, rather than using this expression constantly, we're giving it a name. And we're calling it mid. And now, and that makes sense, right? Because what is this computation doing? It's really giving us the midpoint in the string. So because we're getting the midpoint in the string twice, rather than just calling it both times, let's actually give it a name. We'll call it mid-s. And this is simply just going to give us the midpoint in the string. And as you can see, now our code just looks cleaner. We're going to have 2 design recipes now. We're going to have one design recipe for this function. So design, okay, I need to know how to spell this. I'm not going to mess this up. How do you spell recipe for the last time? R-E-C-I-P-E. Is that right?
Yes.
Okay, R-E-C-I-P. I don't really remember. I'm going to probably forget those, but like, anyways. You need one design recipe for that function, and then you need another design recipe for this function. So you need 2 design recipes. And this is where your assignments, you're going to be kind of annoyed in your assignments. If you're ever going to be using a function or a computation several times, turn it into a helper function and use that helper function instead. The only downside is you're going to have to write a design recipe for that function. Because you have to write design recipes for every function you use. Okay? So going back to the slides, they defined a helper function called mid, and yeah, it just did exactly what I showed you. And then this is the entire design recipe for the function mid. It's the purpose, the contract, examples, implementation, and the test. There's no requirements. There's no requirements. Okay, now from this, we can, so what they're doing is they're defining 2 other helper functions. They're defining a helper function called front part, and it's going to be doing almost the exact same thing that we did, where you're essentially calling front part as substring from 0 to the mid of s. And this is the entire design recipe for the front part. Any questions about that? So they have 4 functions in total. They have this function, the front part, the back part, which is very similar. It's the substring from s of s from the midpoint all the way to the end. And then this is the entire design recipe for the back part function. Okay? And then they're going to combine this all into the swap parts function. And all they're doing is they're string appending the back part and the front part. Now, take a moment and ask yourself, what looks cleaner? This swap parts function, it's very close to English. You're appending, I guess string append is not really English, but like you're appending the back part of something to the front part of something. That looks much nicer than doing quotient on some variable with a string append with a substring. Because that's not really readable. But this is definitely more readable than doing a string append of a substring of a string line. Because we're just string appending the back part and the front part. Now what do back part and front part do? Well, I mean, we made them, so we know what they do, but it doesn't really matter. What matters is that this looks much cleaner than having them all in one big function. So that's the motivation of the helper functions. The downside is, you're right, there are 4 design recipes. There's one design recipe here, there's one design recipe here, and then there's one design recipe here, and then there's one design recipe here. So there's really 4 functions. With my implementation, you only really had one function, and you would only have to make one design recipe. But it was uglier. It looked much worse. The code looked much worse than the code for this. This looked much nicer. So we've introduced a new concept here, a helper function. A helper function is, the purpose of a helper function is whenever you have code that is constantly being written over and over again, you should rewrite this code in a separate function and just call this function. Don't write string append of substring of string length of whatever. Write string append, back part and front part. And then the back part and front part will have the substring stuff in there. Any questions? Yeah?
So it's not a question. So I just want something that's defined, right, with S, A, S, string length of A.
Sure.
And then so when I do like S is 34, you give me 1. That's a string length. So 2.
You have to show me afterwards because I can't understand that just by thinking about it. Helper functions make sense to everyone? If you have some code that is doing something that is really significant, so like if you have the substring from 0 to half, we know what that does. That is giving us the midpoint. If you have something that does something meaningful like that, put it into a helper function. Now you might ask, like, how do we know what's meaningful? How do we know what should we include in one function? Again, kind of use your own intuition. Kind of just, I hate saying don't be dumb, but like, just like use your intuition. That's a better way of saying don't be dumb. Just use your intuition. Yeah?
So with both functions, your function and the function they like 100%?
Yeah, so if you submitted my solution versus this solution to like for an assignment, they would both be fine. You would definitely need the midpoint function. If you didn't have the midpoint function, you would probably lose marks. You shouldn't have just one big function. But in my solution, I had 2 functions. I had the midpoint function, and then I had my main function. In here, they had 4 functions. They had the midpoint, the back part, the front part, and the main. Both of those would be fine. This one, I would say, is better. It is better. But for the sake of marking, both of them would be fine. If you just had one function, you would probably lose marks. And for that, because it's not clean. Your code is not as readable as someone that did it like this, for example. Yeah.
So because like the idea behind helper functions is to use them instead of like writing out the same code over and over and over again.
Yes, for the most
But
part.
in the swap parts function, you only write out the code for front part once and back part once.
Yeah.
So are those helper functions really necessary here?
And so yeah, the question was like, I said that helper functions are used when you have to rewrite code constantly, and it's a way to avoid rewriting code. But in this case, back part and front part, they're only used once. So isn't that going against what I just said about having a helper function that is saving code? And that's kind of yeah. So essentially, the answer to that is yeah. So in this case, they're not necessary. Like I said, my solution would be as fine as the solution. The only difference is the solution is it's easier to read. And as far as whether you need a helper function for this, no, you don't. You could just have that solution with the midpoint as your only helper function, it would be fine. The reason I would say the solution is better is because, well, it's just more cleaner. And the reason it's more cleaner is because they're using more helper functions. So do you need them? No, you don't need them. You're going to get 100% either way. But, I mean, if you want to be a good programmer, if you want to take future courses, this will be better. So yeah, like essentially, in this course, we're not going to be penalizing you marks for not having code like this. But in the future, if you ever have a function that is doing something that can be explained much more clearly by a function name, like back parts or front parts, better to call that function back part and front part as opposed to just write the code in there. But again, if it's only being used once, you don't really need to. If the function is only being used once, like it is in back parts and front parts, you don't really need a helper function there. But like I said, it's cleaner. It looks cleaner, and it does. This code is much more understandable than having a code with substring of string appends. Because you kind of know what this does. It's just you append the back part and the front part. And here's the entire design recipe for this. Any questions? Any questions about this? Design recipe is definitely, I don't want to say it's the most annoying part of the course because it all depends on where you stand. If you're getting 95s on all your assignments and the programming part is easy, then yes, you're going to be pretty annoyed at constantly making design recipes. But on the other end, if you're one of the students that are getting borderline 50s and you're probably failing, do the design recipe because that is your one chance of passing the course. Because yeah, it doesn't take that much intellect, is that the right word? It doesn't take that much thinking as compared to actually coding. Okay, cool. All right, moving on. So we're gonna end this module with one final example that puts everything together. Okay? And in this example, we're writing a function called cellbill. So cellbill consumes the number of daytime and evening time minutes used. So essentially, you're trying to compute your cell phone bill. And the way you're gonna do this is you're gonna write a function that consumes the number of daytime and evening time minutes used, and it produces the total charge. And we're assuming that your phone is charged according to these rules. You have 100 free daytime minutes, 200 free evening minutes, and every time you go past this, you get $1 charge for each additional daytime minute and 50 cents for each additional evening minute. Make sense so far? So what's the contract for this function? What is the type of the first parameter? Actually, do I even know the answer to this? Hold on. I don't know the answer to this yet, so let's just keep going and we'll figure it out. Anyways, okay, so this makes sense? It's probably an int, so essentially, okay, you know what, we'll do it, screw it, we'll do it. So what is the contract for this function? What is the first parameter? It's the number of daytime minutes. The reason I said I wasn't sure is because you can ask the question, are the minutes going to be fractional? Can you have like 0.5 of a minute? And like, yeah, in real life you could. You could have like 500.5 minutes, which is just 30 seconds. So it's actually not clear here whether you're allowed having decimals or not. So that's kind of why I was not sure whether the contract would be integer or a natural number. And same with the second parameter. The second parameter is the exact same as the first parameter. So they're both either going to be natural numbers or integers. Yeah, so essentially the point is that the contract is probably not going to be an integer. Or sorry, it's not going to be a number. And the reason for that is because you can't actually have like 50.75357 minutes. You could, you technically could, but well, actually, we'll see what the contract is. But I want you guys to understand what the considerations are. Like, how do I know why the contract is a confusing part? Because I'm thinking, what does time represent? Time could be represented with just numbers. It could be represented with fractions. We know it can't be represented by negative numbers. So that's the only restriction within our function. We can't have negative. You can't use negative minutes in a phone contract. Okay. So first things first, we have to define meaningful variable names. So daytime minutes and evening time minutes, we could just use the numbers 100 and 200 in our function, but because these are meaningful variables, we should give them meaningful variable names. So day free is 100, evening free is 200, day rate is 1, evening rate is 0.5. Does it make sense why we define these four variables? We define these variables because although we could use 1, 0.5, 100, and 200 within our code, it looks much, much worse to use those numbers as opposed to use variables called day free, evening free, day rate, and evening rate. If you're multiplying something by 100, it is less clear what you're doing than if you're multiplying something with day free. Make sense? That's why we use these meaningful variable names. They're meaningful to our question. The numbers 100, 200, 1, and 0.5, they're not random numbers. They are very, very specific to this question. Purpose. Purpose statement. It produces the cell phone bill for daytime minutes and evening time minutes used. And let's look at the question. Consumes the number of daytime and evening time minutes and produces the total charge for the minutes used. So, very, very similar to the question. And it should be, because your purpose statement should be telling you, well, what the purpose of your function is. And you get that from the question. Okay, so contract, that, and that. So, I was confused, but over here, they say that the contract is that and that. And what that means is essentially, you're not allowed to pass again fractional minutes. You can't have a phone bill that consumed 55.5 minutes. It has to be either 55 or 56 minutes. Now, in real life, I'm sure you probably do get phone bills where you consume 30 seconds or 30 minutes of an hour. And so that's kind of where my confusion came from. I just want you guys to understand why I didn't know the answer right away. And it's because in real life, your phone bill could indeed have fractional numbers. But in this case, they say they don't. Now in your assignments, we hopefully will not be ambiguous about like that. I do think even this is still a little ambiguous because it's hard to know whether you can have fractional minutes or not. And on the assignment, the goal is that we're not going to be this ambiguous. We will be very explicit on what the contract should be. Okay, and these are examples. Then we have the function header, and then we are going to implement it. Let's see how long this is. Okay, it's not that long. Okay. So we could implement this all in one big function, but it's probably better to have helper functions that do a lot of the computation. So what is one useful helper function that we can do? We can make a function called charges for minutes, and it consumes what your limit for free time usage is, and then how much you're going to be charged for each minute you go over. And you can imagine how this function is going to be used in our main function. So this function is going to essentially compute or take in how many free daytime minutes we have, the charge, and then produce a number that just tells you what your bill is, given how many free time minutes you have and what the charge was. And obviously the rate has to be bigger than 0. You can't be getting money for using more minutes than you should be. You're always paying money for using more minutes than you should be. And the code here I don't want to say it's straightforward, but what's happening here? We are essentially taking away how many minutes we've used, or how many minutes we have, from how many minutes